Hello and welcome, Math 1 people. We are continuing our look at statistics today in this final unit of the year. We're going to be looking at dot plots and histograms today. This is a dot plot. It's made from a table, not this table. This was made from a different table, but it's made from a table of data. And it's called a dot plot because there are dots. Very inventive naming here. Okay, so here's what it means. This is about hours that different people slept. Each dot gets to be a data point. So this dot means that person slept 9 hours. It's a picture of where everything is. So we can see, wow, there's lots of people here that got 8 hours of sleep. Look at that. And that's actually where the most popular answer is. It's also really easy to see the range in this. It goes from 4 to 9, so it's got a range of 5. And this thing right here, this big tower of dots, it's also super easy to see the mode. Okay, remember, the mode is the data point that repeats the most. Yeah, there's some repetition on 7, but wow, look at 8. All kinds of people are getting 8 hours of sleep. Nobody else can match the 8. Okay, dot plots are also useful because you can also immediately tell each one of these is a point of data, so you can count them all up. There's 15 of them, so we know that there were 15 data points in our data set. And it's also really accurate because each one, you can tell exactly what each one was. You can tell, well, that dot was 9 and that dot was 4. So it's pretty accurate if you want to recreate the table it came from. So it's a very accurate representation of your data. So we're going to practice making our own dot plot. So I'm going to make a very nice straight line here. And then I'm going to ruin it by making different increments without measuring them because now I'm feeling lazy. Okay, so let's find the smallest number. Happens to be this 11. We're going to scan through here in a second. For the biggest number, there's 21, but there's a 23 over here. That's bigger. Okay, we found the smallest number and the biggest number. So we know our dot plot can start at 11 and it'll go all the way to 23. So there's our 12 and a 13 and a 14. And what you do is you just basically number them off, okay? And there are programs that will do this for you if you want to take statistics your senior year. I know that's still 3 years away, but if you are thinking ahead, you learn about a lot of these programs that will create some of these pictures of data for you. All right, so let's start making dots. These are dots about how old people were when they got their first job. The first dot over there is 17, so I'm just going to make a circle and cross it off. Okay, this person was 14, so I'm going to come over to 14, make a circle, and cross it off. So you don't have to line up the data. You don't have to be in order because it will put it in order for you. And when you get repeating numbers like the 17, you just make more dots on top. 23 way at the end, that's the upper end of our range. Here's another 17, so I'll just make another dot on that pile. Ooh, our first 16. Somebody got their first job when they were 16 years old. 13. 21. Apparently I've decided that 22 is a mode and will repeat on this table. Change that to 21. Okay, we've got another 16, so you just make another dot, and you just make a tower, basically. If you've already got a dot there, you start building a tower. Another 17. Here's the lower end of our range, is the 11. Another 17, this is a big tower. We've got an 18 over here, so we'll just tap that onto the top there. And last, but certainly not least, there's a 16 right there. And very, very quickly, you have a picture of where your data is. Okay, you can tell what ages weren't included. You can tell where most of the data is. So kind of most around here. 17 is going to be the mode. There's the upper range, might be an outlier. There's the lower range, might be an outlier. And again, most of the data is concentrated in the middle. So a very quick picture of what the data means for people who had their first job, or what age they were on their first job. Next up, we are going to be looking at histograms. This is a different type of display, similar in some ways to the dot plots. You can see where big towers of data are. I'm going to go ahead and draw in some horizontal lines because sometimes it's easier to see how the histogram is formed if these lines are more visible, I guess. Okay, this particular histogram is about games per World Series. We're looking at baseball, championship in baseball, for major leagues at least. Okay, depending on the histogram, this can be a little bit different, but the number usually applies to the blocks to the right of it. So that 4, well, yeah, that 4, that entire tower of blocks, all of those were maybe 4 games. We'll talk about that in a second. And there's a 5-game block, and 6 games. Those are all how many World Series went 6 games. It's a best of 7 series, so none of the World Series went 8 games. Now, here's where it's a little bit different from the dot plot. These aren't super accurate as far as representing exactly the data, because everything in there, that could be 6, but it could also be 6.5. Maybe they went 6.5 games because one of the games halfway through was called for lightning. Or 6.1, maybe they had to call off after the first inning because snow hit. They were playing in Canada. Who knows? They were playing Montreal. You never know. So there's a range of data. Okay, so you don't know what the exact data value was. You cannot recreate the table from a histogram the way you can from a dot plot. So in that instance, it's not an exact replication of the data. And it's a little bit easier to see what's going on in this one because half a game of baseball is kind of a strange thought. It happens, but it's not quite as common as, for example, money. Here's where the histogram has an advantage over the dot plot. The dot plot we made went from 11 to 23, so the range is pretty easy to see. But here's a range that goes from 0 to at least 45,000. Well, no more than 45,000. Okay, and I'm going to draw these things in. So each one of these boxes is a data point, but the catch is we don't know exactly what data point it is. Okay, so from here, 0 to 5,000, well, one of the blocks could be 3,000. These are countries per capita income. That's income per person. So this first block is a country, but we don't know exactly what that amount is. We know it's between 0 and 5,000, but we don't know if it's 2,000 or 3,000 or 4,000. And the same is true for all of those. Every block on there is between 0 and 5,000, but we don't know exactly what it is. Okay? And let's say somebody was exactly 15,000, it would be you'd put them in the block just to the right of the 15,000 marker. Or if somebody was exactly 25,000, they'd go right there. Okay, but they could also be 25,001. They could be 26,000. They could be 27,000. So we can't say, oh, this is exactly what the data was. But they're really good if you've got a kind of extensive range of data. Okay, so we're going to make our own histogram. We're going to make a very straight line and then kind of ruin it by making other not so straight lines, but that's okay. Okay, this is Nobel laureates. That's Nobel Prize winners. And I'm scanning here for smallest and biggest number. Found the biggest guy at 79, or the oldest guy. We're looking at how old these things were. Ooh, I see a 31. I don't think anybody is younger than 31. Sung Dao Lee, I believe, was a Nobel Peace Prize winner, I believe. I could be wrong on that. Okay, so we know the lowest, we know the highest, and that's a pretty extensive range, from 31 to 79. I don't want to make that many dots, but what I could do is I could make increments of 5. And then everybody who's between the ages of 30 and 35, so 30 to 34, can go in that first thing. And then I can make another little column here for 35 up to 39, and then 40 will start the next group, and everybody who's between 40 and 45, so 40 to 44, will be in that next column. So what I'm doing here is this is not going to be exact data as represented by the numbers, but we will still get a basic picture of where most of the data is. We'll still see some of the outliers. Okay, so it'll still give us a good picture while not making us make really, really long lines that are kind of not useful once you get them started. If you're making a histogram by hand, graph paper is a really good tool because you've already got these lines drawn and you just need to figure out how big each of your little increments is going to be. So I'm going to basically make graph paper here. And again, if you decide to go into or take statistics your senior year, sometimes I end up teaching that. I actually do make them, I force them to create some of these by hand in the beginning, but then we learn how spreadsheets can make them, we learn how other data programs can make them, and how they can be super useful. And just to be safe, I'm going to give this one more row on top, and then we'll get started with how it works. Okay, just like dot plots, you don't need to do this in any particular order. We can just start right here, 51. So find out where would 51 fall. Probably between 50 and 55. So I'm just going to color that box in. There it is. Okay. I'm going to label here. So there is one Nobel Prize winner. He won the Nobel Prize for physics. It was superfluidity and helium, I think, helium-3. Okay, this guy also 51, and I'm just going to color the box in above it. So it's like putting circles in. 42, between 40 and 45. Our 79-year-old guy is way down here between 75 and 80. Cross him off. Okay, now we have an exact number at 60. Okay, 60 is going to go into the bin. These are often called bins on some of the spreadsheet programs. In the bin to its right. Okay, so just to the right of it. Okay, 40 is going to do the same thing. Okay, now look, we've got that guy was 40, but there's another box filled in that was 42. So that's, you can't say, oh, there's a mode, because those aren't actually the same data points. Those are 40 and 42s, but they're still stacked on top of each other. So that's where they're not quite as accurate in recreating the table as the dot plot. But you still get the basic trends off of them. Okay, here's another 60. Remember, it goes into the bin to its right. 56. Haven't had one of those before, in between the 56 or the 55 and the 60. 31, that's our young guy. There it is over there. You know, there's not a Nobel Prize for math. The story is, well, the more accurate, realistic story is that Alfred Nobel didn't want to compete with a math prize that the Swedes already had, so he just didn't make a category for math. And he was focused on inventions and real-world things. So a lot of these physics awards, a lot of these guys in here were awarded Nobels for physics. Most of them are practical physics, not theoretical physics. All right, we have a 68. It goes in between 65 and 70. And there's a 61. Goes in between 60 and 65. And then Barry James Marshall, 54. I'm going to say that was in biology of some kind. Anyway. Okay, and we have created a histogram. And you can't tell exact data points. You can't find an exact range, but you can get a sense of the range. Okay, you can sense that there's just one young guy there that won a Nobel Prize. And then here's an old guy way up here that won a Nobel Prize. And right there's the age of retirement, or it's right around 65. So looks like most of these guys hit their strides right before they would have hit the retirement age or in their 50s. And that's when most people won the Nobel Prize. So we can see most of the people are there. But again, that's not a mode because not like a dot plot it creates modes, because not all of those bins are 50 or